C4 2014, question 9, the infamous difficult vectors question. This year was particularly bad, although the starting 4 marks are nice and easy. Just find the angle between P and Q. So we just use cos theta is A dot B over the magnitude of A times the magnitude of B. The dot product, multiply the i's, j's and k's and add them up. So I've got 10 minus 4 minus 24. And the magnitude of the vector, you square them, add them and root them. 2 squared is 4, 1 is 5 plus 9 is root 14. Multiplied by 25 plus 16 plus 64. Which is the root of 105. Type that in your calculator and press shift cos, and theta comes out as 118 degrees. Always worth doing twice. It's quite easy to press a wrong button during that process. But for 4 marks, we'll take it. Now the second part looked a bit more GCSE styly than C4. Talking about position vectors in terms of A and B. It says C is the midpoint of OB. All of OB is little b, so that bit there must be a half b and that bit there must be a half b. It says that A is the midpoint of OD, and O to capital A is little a, and because that's the midpoint, that must be little a as well. Now, the first bit actually isn't too bad. It says, show that CD is 2A minus a half B. Okay, let's just bring that back into shot. CD is going from there to there. I'd have to go down there and then across there. So, of course, going down there is minus a half B. Going across there is adding on 2 lots of A. And then just rearrange it into the form they want. Now, the second part. Show that the vector equation of the line CD may be expressed in that form. So the vector equation is any point on the line, so any point on CD, plus some scalar, lambda, some number, multiply the direction of it. And we've just worked out the direction of it. It's 2A minus a half B. Sorry, not in shot there. Just move it up. Well, let's take our point on CD as point C, which we've obviously worked out is a half B. So we can say R is a half B plus lambda, not in shot again, 2A minus a half B. If I multiply that out, I get a half B plus 2 lambda A minus a half lambda B. And then if I tidy this up and factorize it into the form they want, that gives me R equals 2 lambda A, bring the half out, plus a half, 1 minus lambda there, and that's all multiplied by the B there. So that was the middle part of the question done. Wasn't really very C4-ish, but if you labeled the diagram correctly, it wasn't particularly overly difficult either. Now, the next part of the question, I'm just going to fold this down so I can see the question at the same time as doing it. The next part of the question says another vector equation of a line in terms of mu. And it asks for, it tells us they intersect at the point E. And it says by giving appropriate values for lambda and mu, show that it has that position vector. Now the trick here was to know a quick and simple way to eliminate a pair of simultaneous equations. So I'm going to substitute lambda for the coefficient of mu, and I'm going to substitute mu for the coefficient of lambda. Okay, so that's a bit of a cheeky trick. So I'm going to let lambda equal 1/3 and let mu equal 2, and then sub those in and let's see what happens, right? So if lambda is 1/3, I'm going to get 2/3 A plus a half 1 minus 1/3 B, which is 2/3 A plus 1 minus 1/3 is 2/3, a half of that is 1/3, 1/3 B. Now, it's no coincidence that that is what they've asked for there. But of course, we have to do that in the other equation as well to show it intersects. So substituting mu for 2, because that's the coefficient of lambda, gives me this, 2/3 a plus 1/3 2 minus 1b, which of course is 2/3 a, 2 minus 1 is 1, plus 1/3 b. Okay, so being as both substitutions come out as the same thing, that is the point of intersection. And then the last thing, it says give a geometrical interpretation of the fact that E has position vector 2/3 a plus 1/3 b. Well, if it's in terms of a and b, it means it must lie on CD and AB. Show the diagram. It must lie on here and it must lie on here, so the point of intersection must be there. So E is the point of intersection. Well, a very peculiar vectors question this particular year. No need for setting up and showing whether or not they intersect or they skew. But don't think it won't come up again, so make sure you are quizzed up on your GCSE position vector work. Thank you very much.